Hello and welcome to the Briefing Chat podcast, the Friday show where we talk about a couple of stories that have been highlighted in the Nature Briefing. I'm Nick Petrichow, and joining me this week is Shamini Bundell. Shamini, what have you got for me this time?
Oh, I've got some good news science.
Yay, I love good news.
For a change. Yeah, this is a topic that we've covered for many years on the Nature podcast, on video, and it's about brain-computer interfaces.
Right.
So this is just this really cool concept that you can read minds, you can translate patterns of firing of neurons in the brain into something, they're electrical signals. You can then read them with a computer and translate them into, well, in this case, mostly typing, but things like movement and things like this. And the reason this is a sort of really nice good news story is this is an example of a participant who's been using a brain-computer interface at home for the last 2 years very successfully. So this isn't, just occasionally as part of a study. This is integrated into this person's everyday life and massively improved their life. And this was reported in a paper in Nature Medicine, and I've been reading about it in a Nature article.
So normally, as you say, it's the case that people are doing this for a short-term thing, maybe for an experiment or something like that to see how it works. But this person's been using it for a long time. And what sort of kind of brain-computer interface is this? Is it speaking for them, typing? What is it doing? What is it translating, I guess, to make into something that can be understood by others?
Well, enough different things that this person, Casey Harrell, can continue in their job. They can operate a computer, send text messages, emails. He has a job in climate advocacy. And so he has amyotrophic lateral sclerosis, which is a type of motor neuron disease. And he was diagnosed with that 6 years ago. And this brain-computer interface that he has, which is sort of part of a study, but it's full-time in his house available to him. And it allows him to communicate with an average speed of 56 words per minute in terms of typing, which is pretty decent. To get a sense of it, I went and did one of those typing speed tests, and it came out as 70, which is, I think, above what would be generally average if you included sort of young people and old people across the globe. So yeah, 56 words per minute is very decent. And this has really had such a huge impact on this person's life. He describes it as nothing short of revolutionary, and says, this has allowed me to keep working and earn money and insurance from my family. This is reconnecting me with friends and family who are too shy or too afraid to come over and not be able to understand me.
Oh, wow. So certainly a transformative effect on this one particular individual's life. But are researchers hoping that something from this could be used to try and do this a bit more widely?
Yes, as I said, we've been covering these kind of stories for a while, and they are moving away from the lab and into being an actually applicable medical device. So as I mentioned, a lot of the more advanced devices tend to be used as part of studies where perhaps the participants will go into the lab and use it in specific sessions, or there are some at-home ones, but they're not as advanced. So this analysis of sort of 2 years of use is basically, the co-author says, the most extensive data set and the longest running speech communication for anyone with this kind of an implant. And another researcher noted this difference that these brain-computer interfaces are now really becoming a medical device instead of a research tool.
I mean, yeah, I guess communicating with one another is so core to who we are as humans, and hopefully this will be a boon for people to come. But, I wonder, were there any sort of long-term effects? Sometimes these involve probes in the brain and that sort of thing. Was there anything that people have to figure out for the future of this technology?
Yeah, no, I should say this does, as with all the others at the moment, include microelectrodes being implanted in the brain. This isn't something you can pop out and stick on your head. And because of the current setup, it can only currently be used at home as well. So definitely there's a hope that you can start making this more portable. That'd be one great thing. They're also working on brain directly to speech.
Okay.
So that it can talk instead of just type. At the moment, they do have a text-to-speech that then uses that person's voice from before they were diagnosed so that they can speak in that way, but it's not direct. And that's definitely something that obviously they would like to use. And another really interesting thing that's mentioned here is that they added a privacy mode so that, obviously this person in their own house, everything they're doing is being sent to the researchers, and you might not want everything you type to everyone to be part of a research study. So they've added this privacy feature, and one of the co-authors said they wanted to set a good example for what a speech BCI, brain-computer interface, might include in future forms as companies start to expand on it.
Very interesting stuff. And yeah, it does seem like this technology is rapidly evolving. So I'm sure we'll continue to cover it on podcast and in video. But I think we can move on to my story this week. And it's another tale from the land of obesity drugs. Every other week, we seem to have more news on the things that these drugs do. And this was a story I was reading in Nature about how they may boost testosterone and sperm quality.
And just give me a little recap on these new obesity drugs. What are we talking about?
Yeah, so most obesity drugs that people will be familiar with, they work by binding to the same receptor as a natural hormone called glucagon-like peptide 1. And so by doing that, it makes you feel full, essentially, and it stops people eating as much, and therefore they lose weight. That's generally how they work, and they're often prescribed to people who have obesity or who have diabetes, as they can be effective for that. But as we've spoken about many times on the podcast, these drugs seem to have a range of other effects as well. They can help with heart health, liver disease, and all sorts of other things that you wouldn't necessarily think of when you're just relating them to obesity and diabetes and things like that. So this particular story is about a systematic review that was presented at a conference recently. And yeah, as I say, it seems to suggest that testosterone levels and quality of sperm may increase when people take this drug who are obese.
Wait, so only this sort of boost in testosterone only works in obese people?
That seems to be the case. So what this study did is it looked at randomized controlled trials that have been done that had some measure of testosterone and sperm quality. And of all the randomized controlled trials that have been done with these obesity drugs, they found 5 that met the criteria. And of those, 3 of them were in healthy individuals, and it didn't seem to have any effect on their testosterone or sperm quality. But in people who are obese, it did seem to increase the testosterone and the quality of sperm. Things like the shape, the size, and the count of the sperm are the things people look at for that. And one was particularly interesting because it looked at people who were either given one of these obesity drugs or they were given testosterone replacement therapy, which basically just gives you artificial testosterone to try and replace the lost testosterone. And in that particular study, they showed that in obese people, if you gave them testosterone replacement therapy, testosterone went up. It went up quite a lot. It went up more than those with the obesity drugs. But the people who had taken the obesity drugs, their testosterone went up, but also their sperm quality improved, which wasn't the case for those who'd taken the testosterone replacement therapy.
And is low testosterone an issue associated with obesity?
It is, yes. So in some ways, this isn't particularly surprising because it's known that fat cells contain enzymes that convert testosterone to estradiol, which is one of the main female sex hormones. So if you are obese, then you'll have more of this enzyme and therefore you'll have more testosterone converted into estradiol. There's also metabolic changes that are associated with reduced testosterone and obesity, and also inflammation caused by obesity can affect testosterone production as well. So it's not necessarily surprising, but it could be really informative to endocrinologists who are treating people who are planning to conceive. If they're obese, rather than giving them maybe testosterone replacement therapy, as we discussed, perhaps one of these obesity drugs would be a better fit, or helping them with lifestyle changes that could help them lose weight in other ways. Of course, though, this is all very preliminary. As I said, this was based on a conference proceeding that has looked at different randomized controlled trials that weren't necessarily looking for this, but it was part of the study. So there'll need to be bigger trials to look at this more fully. But yeah, it does seem to be quite a promising effect.
And so presumably this is sort of finding the results of the trial, but not necessarily going into the mechanism. We don't necessarily know whether it's the drugs that cause the effect or the weight loss. We don't necessarily know exactly how these drugs are impacting particular pathways in the body.
No, exactly. And, there'll be a lot more studies to be done. And there are a lot of studies coming up this year about these obesity drugs that should give us a lot more insights. Because as I say, this is one of many effects that have been found of taking these obesity drugs. And it may be to do with losing weight, but there is some evidence that maybe some of the effects could be to do with taking the drugs themselves. It's not really clear at the moment. So there'll be a lot more information coming out soon about how these drugs work and how they could potentially help people.
Which is really key, because if they've got a load of effects that we don't know about, it's great that we've seen lots of positive effects so far, but obviously there's sort of potential worries if you don't know exactly everything that the drugs are doing, that they could be having potentially negative effects as well, depending on interactions with other conditions, things like that. It seems pretty important to understand what's going on.
I mean, one of the things is that these drugs have not been around for that long, so we don't know the long-term effects of them, and that will only become apparent as people take them and we see how it affects them. And part of the reason we're seeing many of these effects that weren't really considered before is a lot of people are now taking them. So I'm sure there'll be more of these things that researchers will pick up, and they'll certainly do long-term studies to try and understand. But yeah, as you say, it'll be good to get that information, and there have been negative effects reported as well. Some people have reported like anxiety and depression when using these drugs, and it sort of modifies activity of the brain. So there's things to consider there. But for this particular thing, at least, it could be a positive for people trying to conceive who are obese. Perhaps this may be a way to help them do that.
Yeah, well, I think that counts as another positive news story. I think we've done very well on the Briefing Chat podcast this week, bringing you some positive science. So if you want more stories of this kind, I can't promise they're all positive, but they're all fascinating. You can sign up to the Nature Briefing. It's a daily email newsletter, and we'll put a link in the show notes if you find that, where you can click on it and sign up.
And if you want to keep in touch with us before you hear from us again, you can. We're on email, of course. We're podcast@nature.com, or you can follow us on social media. We're @Nature Podcasts. I'm Nick Petrichow.
And I'm Shamini Bundell. See you next time.